In example 4, let's again factor out our two terms using the greatest common factor. I adjusted this problem slightly, and you'll find out why in just a moment. Let's break down 64m cubed. So remembering that we want to work with primes. 64, sure, it comes from 8 times 8. But where does 8 come from? 8 comes from 2 times 4. Well, 2 is prime, but 4 is not. So 4 comes from 2 times 2. And then we said it was 8 times 8. 2 times 2 times 2 makes 8. And we have another set of 2's for that second 8. All right. So the first 3 2's came from the first 8. The second 3 2's came from the second 8. And as the case would be, I have an m cubed. So let's acknowledge all 3 of those m's. Down here below, I have an 8m. And as we discovered just a few seconds ago, 8 comes from 2 times 4, and 4 comes from 2 times 2. And there's our m to go with it. There's quite a bit happening in this problem now. I have 3 bundles of 2's. So what does that do for us? It tells us that we have 2 times 2 times 2 and a bundle of m's. We also see from up here the dissection of our first term that I have 3 remaining 2's and 2 m's. So we'll shorthand that with an m squared. And there's a minus between these two terms. Now there is nothing left over from our second term of 8m. And we said in the introduction that if everything gets used in the greatest common factor from a term, then you acknowledge that there had been a term there by placing a 1. Let's clean this up. Time for our final answer. 2 times 2 times 2. Well, that's 8. And an m right there beside it. Open your set of parentheses. 2 times 2 times 2 is another 8, with an m squared minus 1. Close your parentheses. This is our final answer, having adjusted our original problem so that we had 64m cubed minus 8m, and we are able to show lots of bundles, and an entire term was used in the greatest common factor. There you go.